Find the second derivative g double prime of x for the function g of x equals x squared divided by x squared plus 2. Then evaluate g double prime of negative 2. So g of x here is the quotient of two functions. We have the x squared divided by the x squared plus 2. So our first derivative will make use of the quotient rule. The first derivative, g prime of x, will be the derivative of the numerator, 2x, times the denominator left alone, x squared plus 2, minus the numerator left alone, x squared, times the derivative of the denominator, which will be a 2x plus a 0. And then that entire thing over the denominator squared. Now in the numerator, we're going to distribute the 2x into all of that, and that will give us a 2x cubed plus a 4x, and then we'll multiply these here, and that'll give us a negative 2x cubed all over the denominator squared. And we can combine like terms together in the numerator. These actually will cancel, and we're left with 4x over x squared plus 2 squared. And we therefore have a quotient, and we will make use of the quotient rule for the second derivative. It will be the derivative of the numerator, 4, times the denominator left alone, x squared plus 2 squared, minus the numerator left alone, 4x, times the derivative of the denominator. Now the denominator is a quantity to a power of 2, so we bring down the power to leave the inside alone, subtract 1 from the power, which will be to the first power, and then multiply by the derivative of the inside. And then all of that is divided by the denominator squared. Now in the numerator, we have a 4 times x squared plus 2 squared for our first term. Our second term, we combine all the constants. We have a 4, a 2, and a 2. 4 times 2 is 8, times another 2 is a 16. So we have the negative, we have a 16. We also have an x and another x, so an x squared. And we have x squared plus 2 to the first power. Down in the denominator, we have x squared plus 2 to the 2 to the 2 again. And raised and raised again, you multiply those exponents, so that'll be a power of 4. In the numerator, we actually have a common factor of x squared plus 2. We have a power of 2 and a power of 1. We can factor out a power of 1 from there. At that point, we'll be able to cancel with one of them in the denominator. We have it to a power of 4 in the denominator. If we factor it out, we're going to take out one of them here and the entire one there. There's what we're going to have left. We will have a 4 times x squared plus 2, and then minus 16x squared, and then all of that divided by x squared plus 2 to the fourth power. And now that we factor it, we can actually cancel that down with one of them here, leaving us with a cubed in the denominator. So g double prime of x will be, in the numerator we can distribute that 4 in, so we will have a 4x squared plus an 8, and then we have the minus 16x squared, all over x squared plus 2 quantity cubed. We can combine like terms together in the numerator. A 4x squared and a negative 16x squared can be written as a negative 12x squared. We have plus 8, and then all of that over x squared plus 2 quantity cubed. So there's the factored and simplified version of g double prime of x, the second derivative. The next thing we want to do is evaluate g double prime of negative 2. And that means to plug a negative 2 into each of the x's in the second derivative. we have a negative 12 times negative 2 squared plus an 8 divided by negative 2 squared plus 2, and then quantity cubed. So we have negative 12 times negative 2 squared is a 4 plus the 8 all over. Negative 2 squared is a 4 plus a 2, and then cubed. In the numerator we have negative 12 times 4, which is negative 48 plus 8. And in the denominator we have 4 plus 2, which is 6, and then cubed. Negative 48 plus 8 is a negative 40. And then 6 cubed, 6 times 6 is 36, and times 1 more 6 is 216. Now these are reducible by at least a 4, so let's take a 4 out of each of them. That'll give us a negative 10 over a 54. And then we can take another 2 out of them, and that will give us a negative 5 over a 27. It doesn't look like we can reduce any further, so we'll leave it as that, negative 5 over 27.